Hello friends, today's question. A block P of mass m is placed on a horizontal frictionless plane. A second block of same mass m is placed on it and is connected to a spring of spring constant K. The two bodies are pulled by a distance A. Block Q oscillates without slipping. What is the maximum value of frictional force between the two blocks? So we have these two blocks Q and P, spring constant K, and a force is being applied, and it is not mentioned on which block it is applied. So it means if we apply the force in any of these two blocks, the condition, if it satisfies that it moves with the same, you can say they oscillate together without slipping, it means P and Q should be moving always together, then the value of maximum frictional force we have to find out. And it said that it is pulled by a distance A. Okay, so A is its maximum, you can say extreme point to which this combination of P and Q is being pulled. Okay. So first of all, let's try to understand the condition for no slipping. So we can say no slipping condition. So it says that block Q oscillates without slipping. You can say for block Q to oscillate without slipping, on block P. On block P, so it means their acceleration should be same. Their acceleration must be same. So which basically means that the static friction which is responsible so that both block Q and P moves together. Okay. So you can say that therefore static friction between two blocks is responsible for making both blocks accelerate together. Static friction between two blocks P and Q is responsible for making both blocks accelerate together. And now we are going to find out, we already discussed that what will be the no slipping condition. So it means it is a static friction which is responsible so that both the blocks move together. Now it is said that the blocks are pulled by a distance A, so we are going to find out its angular acceleration, we are going to find out its angular velocity, and for that particular angular velocity, as the distance is pulled to A, where A is the maximum distance from its mean position, from that we can going to find out the maximum acceleration for the SHM. And if you find out maximum acceleration, we can find out the frictional value. So next we are going to find out angular velocity of the system. Angular velocity of the system. A system means P plus Q. Now the system is P plus Q. It means that both P and Q are going to behave as a one block. You can say that system of two blocks behaves like a single block of mass 2m. As they are moving together, as they are moving together as one unit, which basically means no slipping. So we can just draw a rough approximate of that we have spring, this is of K, and now both P and Q are moving as one system and their combined weight is given as 2m. Okay, and there is no friction between, basically it should be Q and P. So there is no friction between the P block, lower block rather, and the you can say the ground. Okay, so the combined mass is of 2m, and this is the basically wall. Therefore, the angular velocity, the angular frequency omega will be equal to K divided by m, and m is the total mass, which is given as 2m. And in case of your SHM, we can say that the maximum acceleration in SHM, so maximum acceleration is going to occur when the displacement is maximum, that is at A. You can say that in SHM, maximum acceleration occurs at maximum displacement which is given as A. Therefore, maximum acceleration, if represented as A max, will be equal to omega square multiplied by A. Substituting value of omega, we get K divided by 2m whole square multiplied by A, and this gives us Ka divided by 2m. So we found out what will be our maximum acceleration, that is given as Ka divided by 2m. Now we are going to find out the maximum frictional force. Maximum frictional force, okay, which is our F max. So the frictional force must provide maximum acceleration for the block Q to move in sync with block P. Okay, that is a condition. So we can say that frictional force must provide maximum acceleration for block Q to move in sync with block P. Therefore, the frictional force F max will be equal to mass into A max, and we already know the maximum acceleration, which is our mass into Ka divided by 2m, and here m cancel with m, so we get F max is Ka divided by 2. So this is the maximum value of acceleration, or sorry, maximum value of frictional force between the two blocks. This is maximum value of frictional force between two blocks, between two blocks. So if we say check the option number A is the correct option. Option A is the correct one. Option A is correct. And we can also find out the direction of this frictional force. Okay. So for the direction of the frictional force, direction of F max, it depends in which direction the restoring force is acting. So we have a spring and we have a body Q, and we keep you can see draw P by keeping a slight gap between Q so that we can easily represent the forces. So this is K, and we have a restoring force that is in this direction. So this is our restoring force. So both the blocks should be moving together. So spring will try to force the Q to move toward left, and the frictional force between Q and P will be such that for P to move together with Q, it should be also moving in the direction of the restoring force. So we have the force of friction will be acting in this direction for P. So this will be our F max, and because of the action and reaction, we are going to have F max for Q acting in opposite direction. So this is our first. And if we have restoring force in the opposite direction, so if we have, this is a spring and we have Q, and this is our P, this is spring, and in this direction now we are having the restoring force. So it means that we want the Q will be moving away or towards the right. So for P to move towards the right, we are going to have F max in this direction towards the right. So this will be our F max, and for Q it will be acting in opposite direction. So this will be our F max on Q. This will be, we can also find out the direction if required for what will be the direction of the frictional force. It basically means in which direction the restoring force is acting on it. Okay. So from here we can say that frictional force ensures that the relative motion between the two is 0. Between P and Q is 0. This is a basic premise of this discussion. So from here we can say that frictional force ensures that relative motion between P and Q is 0. This is the basic purpose of if they want to moving together. So this completes the question. Thank you.